Hi, so after brief introduction about number system, it's time to discuss some of the main important expected question, okay, which can be asked in your gate 2023 or already has been asked as well, right? So let's directly jump into the whiteboard and start discussing about some of the basic concept, okay, basic concept based questions, right? So you have to follow this session till the end, so you will learn many questions, okay, and how to solve them. So let's directly jump to the whiteboard and start discussing about the problems, right? I hope you might have understood the number system and what are the number system we are going to talk about, right? So let's directly talk about the problems. So here, very first problem I'm just going to take here is, the very first problem which you can expect in the gate examination is find the number of bits, no, or you can say find the number of bits required. Find number of bits required to represent following decimal number in binary. To represent following following decimal number in binary. Number in, okay, so this is a question, and let's see what decimal number is given here. They have given 7683. The base is 10. So we have to find how many number of bits we require, okay, how many number of bits we require to represent this decimal number in binary. So what we have to do here is we have, as we know that the base of the binary number system is 2. Okay, so you have to take this number, right? I mean, you have to take this decimal number and you have to find out the n value, number of bits. Okay, so 2 raised to power n should be greater than 7683. This is the first method you can use, right? Now you have to express this 7 to 7683 in base 2 so that you can equate the power. Okay. You have to find basically the n value. So, okay, so if you remember one table which I'm going to give you, right? So if I ask you that, what is, 2 raised to power 10? You can directly tell that this is 1k, right? Or you can say this is 10 right? So these things will be also useful to talk about memory size and all, right? So 2 raised to power 10 in binary we call it 1k, right? And this is going to be the size of the memory, that is 1024. 2 raised to power 11 if I say, right? It is going to be just multiply with 2. Okay, so it is going to be 248, right? And 2 raised to power 12, right? So you can say this is going to be 96. If you remember this, so you can write all these things. And 2 raised to power 13, you can call it 8192. And 2 raised to power 20, okay, we call it 1 mega. So 2 raised to power 10 is 1 kilo, 2 raised to power 20 is 1 mega, okay, which is equal to 10 raised to power 6. And 2 raised to power 30, can call it 1 giga. This is 10 raised to power 9, and 2 raised to power 40. You can call this as 1 tera. 1 tera means 10 raised to power 12. So you have to remember these things. Okay, if you remember these things, then easily find out the number n. Okay, I mean number of bits from this. Okay, otherwise you can also compute n is greater than. You can take the log both side. Okay, you can take log both side base 2. Okay, so you will get this the number of n value. So if you see here, um, this number, that is 7683, is very close to this. Okay, is very close to 8192, right? It is greater than 4096 and it is close to 8192, right? So the number of bits we require to represent this decimal number in binary is what? you can say it requires n is equal to 13. So how we can find the number of bits logically. Okay, so logically, if you want to find without taking the log and all, you can take log of both side base 2. You will get approximately 13 number of bits you need to represent this decimal number in binary. So I hope this question is done, right? So let's take the part B here. So they have given 10 raised to power 6. Okay. So how many number of bits are required to represent this number, right? 10 raised to power 6. So what you have to find here is you have to find number of bits. Again, what you can do here is again as the very first method is what? The very first method is you have to remember this table, right? So 10 raised to power 6, okay, is what? 10 raised to power 6 here you have seen, and the number of bits required is 20, right? Here 2 raised to power 20 is equivalent to 10 raised to power 6. 10 raised to power 6 you can say is 1 million, right? 1, okay, 1 million, okay, or 1 mega. Sometimes we call it 1 mega as well. So you can say that the very first method what you can use is uh, 10 raised to power you can say 2 raised to power 10 is what? It is approximately 10 raised to power 3. Approximately, not exactly equal, because we know that 2 raised to power 10 is basically 1024, okay, 1024. So we are just equating, it is approximate, right? Uh, e- exactly it is 1024, but it is near, 1000 is near to 1024, right? Okay, so you can take the square of both sides, right? So 2 raised to power 20 approximated as 10 raised to power 6, right? So you can say this as the number of bits required, n is 20 to represent this. If you remember that table, that is 2 raised to power 10 is 1k, 2 raised to power 20 is 1 mega or 1 million, you can say, and 140, 2 raised to power 40 is 1 tera. So you can easily directly you can tell, or what you can do here is the second method is 2 raised to power n be greater than or equal to 10 raised to power 6, and take the log of both side. You can take the log. This is the method 2 I'm telling. Okay, if you want to do some mathematics here, so you can take the log and log base 2. Here n log 2 and base 10 you have to take here, right? Greater than or equal to 6 log base 10. What you have to do here is take log both. Take log side, then you will get here. So you can say from here n is going to be equal to 6 upon. So it seems quite complicated because now you're doing some math, right? 6 upon log. I mean log 2 is here and base 10 is here, right? So this is going to be what? 6 upon 0.301, which will give you n equal to number of bits. This is method 2. I think method 2 is also good. Okay, can do. So what you have to remember here is you have to remember some key points. Key to remember what? Suppose you have got n bits. N bits means what? You can expect 0 to raised to power n minus 1. Okay. And suppose you have okay, the maximum range of the number you can expect is maximum digit you can expect if you have got n bit, that is 2 raised to power n minus 1. Suppose you have got n equal to 4 bits. The maximum you can represent is 0 to 15. Maximum number, maximum digit you can say. N equal to 8 can represent in decimal, that is 0 to 255. So if you want to represent decimal number 255, how many bits are required for 255 is 8. Okay, because and you if you have got like this, suppose 2 raised to power n, greater than 19.06. So what is the value of n? You can say n will be approximately 20. Like this you have to keep in mind. Like this you have to keep this is very important to remember. So number of bits is the very first question which you can expect. Number of bits. Now what we will do, we will take second question, right? So I hope you might have understood the very first question, right? And let's take second question. Second question here is you have to find the number of ones in the binary representation. Question number second. Find number of ones. Number of ones. Find number of ones in the binary representation. Binary representation. Okay, so you have to remember those things like 2 raised to power 10, 2 raised to power 20. Okay, because that those values will be also useful to represent size of the memories. Binary numbers, binary representation of the following the decimal number, right? You have been given decimal number, right? And you have to find number of ones. So how many number of ones are there in binary? So let me take one problem here. That problem is, suppose you have got what this your by 10 is given, that is base 10 is given as 3 into 4096 given plus 5 into 256 given plus 1. So this is given and you have to find the number of ones. You have to find the number of ones. So what is this and what is this? Okay, so you can write this as 1 into 10 raised to power 10 raised to power 0. Okay, and here you can say that next should be what, um, 16 power 0, 16 to the power, you can say 2 into 1, right? And then you can say that here they are given 5, so yeah, you can 5 because 16 into 16 will be what you can find out. And this is 16 to the power, this is what the given is. You have to identify the pattern. Okay, whenever this question will be given, you have to find the number of ones. You have to figure out this. You can say this is 16 raised to power 0, 16 raised to power 2, 16 raised to power 3. Now what you can do here is you can write this as okay. You can further write this as 3 into 10 raised to power 3, sorry, 16 raised to power 3 and 5 into 10 raised to power 16 raised to power 2 plus, okay, plus you can say that 0 into 10 raised 16 raised to power 1, because you can see there is no uh, digit, okay, which correspond to this weight, that is 16 raised to power 1, okay, and 1 into power 0. Now what you have done here is you have converted this in hexadecimal, right? So because if you will convert into hexadecimal, so you can easily convert into hexadecimal to binary. Okay, so you can easily count the number of ones, right? So you have got 3 into this, so this will be given, okay, and you have to convert into hexadecimal, okay, and then convert into binary. So for each hexadecimal digit you have to write corresponding 4 bits. Okay, so this you can now pick up. This is 3. Okay, this is 5, 3501 in base system. So this is what they have given. They have given in this manner, so you don't have to get confused, right? Because you know the positional bit system, you know hexadecimal. Okay, how to convert hexadecimal into binary, that is very easy. So what you can do here is, what I have done here is I have just collected these digits. That's it. So these are the positional weight digits. Now you have got 3501 hexadecimal. What you can do, you can write corresponding number of bits. That too you have to write 4 bits for each digit, because in hexa there should be 4 bits for each digit. You can say that 3 is what? 3 is basically 0, 0, 1. 5 is 0, 1, 0, 1. You can use this concept 8241. And 0, 0 means 0, 0, 0, because for 0 there is a 0, 0 and 0, 0, 0, 1 in binary. Now what you can count here is, you can count number of ones. So how many number of ones are there? 1, 2, 3, 4, 5. So number of ones, it will be 5. This question. The answer for this question is 5. What I have done here is, they will give you, they, if they will ask you what, find the number of ones in the binary representation for the following decimal number, right? So they have given this decimal number. Okay, so what you can do here is, you can convert into hexa, because you can see these kind of a weight is given. I mean, okay, 256, 4096. Okay, so you can easily identify the pattern and write them and convert into hexa, then convert into binary. Number of ones you can get only in binary. I hope this makes sense. So this was the second question which we can expect. So first question was number of bits. Okay, first question is what? Number of bits. Next is what? Let me next. Let's take next question. Number 3 you can. So the question number 3 you can expect is, in a positional weight number system, right? In a null weight number system, the range of the numbers they have given, right? The range of the range of number range of numbers are -3 base 10, 3 base 10. Okay, this is positive and this is negative, represented as represented as represented as P A 0 1 2. Okay, then represent 81 in this number system, right? Then represent 81 base 10, okay, in this number system. Okay, so they have given you the number system here, right? They have given corresponding in a positional weight number system. Okay. In a positional weighted number system. Okay, the range of the number is -3 to +3, which is represented as CBA 0 1 2 3. Okay. Then we have to represent 81 base 10 in given number system. Okay, so the number the base, I mean, the very first step you have to do is what? The very first step to solve this question is solution we will discuss. So step number 1 is base. You have to find the base. You have to find the base, right? if you would be able to find the base, right, then you can easily solve this kind of a question, right? So how can you find the base? That is very, very important, right? You can see 8 1 is given, right? 8 1 is given in decimal. They're asking 81, right? 81 in decimal. 81 decimal. So we can find the base here, right? So in a positional weighted number system, the range of the numbers are -3 in decimal to +3 in decimal, represent as CBA 0, 1, 2, right? It is quite, I mean, quite a different question, right? You might not have faced this kind of a question. Okay. So step one is be what? You have to find the base. Then step two, step number one. Step two will be what? You have to convert this decimal number in that base. Whatever base you have got, right? Understand? Whatever base you have got, you have to convert that. Then, okay, so you will be able to represent. Okay, so if you got the base, because they have given the number system here, right? They have given some symbol as well, but they did not mention what is the weight of this, what is the base of this number system, right? So how can you find the base? Anyone? Okay, so in the yeah, so in the no, can mention what ways you're going to get, because finding the ways in the question is very important. You can comment in the comment box what ways you're going to get for this. Yes. So how can you find the base? Base is basically what? Base is what? What was the definition of the base? I think I have told you. The definition of the base is basically the number of digits in the number system, right? You know, base is what? The number of digits in, right? This number system is given here. So how many digits, how many symbols are involved? So you can see 1, 2, 3, 4, 5, 6, 7. So what is the base of this number system? It is 7. You have got the base 7 and you have to convert this to base 7. That's it. This is a question, right? So identifying the base is very important. Okay, so this question is also very good question, right? Most of the student get confused, okay, by looking at these symbols like A03. So they think like that CBA is given. So it might be the 16 base number system or kind of. In a positional weighted number system, the range of numbers are -3 +3 represented as CBA 0, 1, 2, 3. Then the represent 8110 in this number system. So I don't know what is the base of this number. So I found the base is 7. How I found? We got to see number of from the definition itself. What is the definition of base? Base is defined as the number of digits in the given number system. I hope this makes sense to everyone. Okay, right. So let's go and convert. Okay, if you want to convert any decimal number system to any base, right? Any base, what do? You have to perform successive division and collect the remainder. So 7 is here. Divide this. Okay, 7 and 7, right? Okay, and 7 and 7 you can say. So what remainder you will get? 12. Next, you can divide 7. Okay. Again, it will go one time. So you okay. So yes, so I think 81, and this was, let me do again successive, because as we know that if the base is 7, so no digit should be no crossing, no digit should be crossing what? The more than the base, right? all the digit in the number system be less than the base. That you have to take care, right? 81 is there, and we have to divide by base 7. So you can see this is going to be 7 1 just 7, you can, right? And yeah, this will be what? So if you will take like this, right? So what you will get here, you will get as this is be I think it will be 0 here, right? Because performing the division according to the given number system is very important, right? You can see here this is 0, this is 1, this is 2, 3, right? So how C is represented here? What do you think? What is the value of C here, right? In number, if you write, okay? So you have to think about this as well, okay? You have to think about this. So C is basically here -3, because the numbers are, let me write here so that could perform successive division properly. So your number system is ranges from -3, base 10 is there, right? Plus 3, and it is the symbols are for this kind of a number system, okay? This is the range they have given. Symbols are like C, B, A, 0, 1. So for the good question, you can invest time to learn. Once you will learn, you will be able to solve any question then. So this C belongs to what? This C is basically -3. This is -2, -1, 1, 1, 2, 3. Because the maximum range in negative direction, if it is -3, and this is +3. Okay, 1, 2. I hope this makes sense to everyone, right? So -3 is allowed, -2 is allowed, -1 is allowed, 0 is allowed, 1 is allowed, 2 is allowed, 3 is allowed, and nothing else is allowed. Okay. So I hope this makes sense. So you can go for negative remainders as well, right? So if I see here in this successive divisions, what you can do here is, okay, don't go for one time. Okay, you can say we are going for 12. Okay, 12 times. So 12 into 7 is 84. So 81 minus 84 will be what? Will subtract. So it will be -3. You can say this is C, and then you can go for 2 times, right? So again you will get 12 minus 14, get -2, can be designated as B. Okay, and then you can go for 70 this, you will get 2, okay, because 2 is allowed, symbol 2 is present here, you can see in the given number system. So yeah, so this question is very good question, and it is completely different from, okay, the same story we are doing, but this time they have given some different numbers symbols, okay. From this question we are learning more. Now you can collect from bottom to top, okay. Now you can collect from bottom to top. What is 81, the given number system? That is BC. The base is 7. This is the answer. I hope this makes sense for everyone. I hope this makes sense for everyone. So this is the question, and you have to keep in mind. Let me recall this question again. In a positional weighted number system, the range of numbers are -3 plus 3, represented as these are the symbols which are allowed in that base, that number. Then you have to represent 81 in this. The very first step is you have to determine the base of this number system, and I got 7. How I got 7? From the definition itself. I have told you the definition in the very beginning. What is the definition of base? You have got to see. So let's move to solve next question, because we have solved this question. We got to understand, right, what is the answer for this question, right? Next is The problem, next problem, right? Question number, you can say 4, I guess. Yeah. Find the base of the system. You have to determine the base of the system. Okay. Find the base of the they will give you some operation here, some numbers will be added and you will get some result over there, and you have to find the base, in which base system you are adding those two numbers, right? So you have to find the base here. Suppose this is given as 47 plus 34 is equal to 80. So if you see in case of 47 and 34, right, if you add in decimal, so what you will get here, you will get as 7 plus 4, that is 11, get carry 1, and 7 plus 3 sorry 4 plus 3 is 7 plus 1, that is 81. So in case of decimal number system, right, if suppose they are given in decimal, so you add this, okay, you will get 81 as the answer. But here you can see 47 plus 3 4 is equal to 80, so you can't say that the base is 10 in this case, right? The base is different here, so how can we find base? That is the question. So what we can do here is, let's consider, okay, let's consider here, let let b be the base, right? Let base, your base is b here. What we can convert here is, we can convert both LHS and RHS, right, into decimal, okay, into decimal, considering the base b. So okay, so what we can say here is that 47 can be written in base 10, okay, okay. And we are considering the base is b and we are writing in decimal system 7 into corresponding base, that is power 0, 4 into power 1, the decimal system, right? And then what we can write here is that we say that this is into base to power 1 plus 4 into base to power 0, 8 is again base 10, and so that you could find the required base. This is b, 8 into 10 raised to power 1 plus g. Now what you can do here is, you can further solve this. Solving this will be 4b plus 7 plus 8, 80 plus 0. Forget about 0. So you can see this is 7, 4 plus 3, that is 7. Further solving 7b plus what? 11 equal to 80, sorry, 8b here. It is not, here we have made mistake, right? Please correct that, okay? This should be, b power 1. It will be 8b, not 80. So now we can write this is 8b, 8b. So let me go ahead and further find the b. So b is going to be what? 11. So I hope this makes sense. So you can find the base of any system given the question, right? So you have to find the base of this 47 plus 34 is equal to 8. So how you have got 80 in base 11. Okay. So this is how we can find the base. Now we can take one more problem where we have to find the base. Now they have given the form of, you can say, 302 fractional they have given, right? 302 and 20. You have got here as 31.1. What you have to find here is the base. Find Okay, find the base. So what we can do here is, again, we have to consider this is 302 base B, okay, and 13 point, can write like this, and then say 3 in that is e raised to power plus 0, then 2 raised to power 1 plus B will get here plus 3 and plus 1 by B, because this will be having, right, because it is next to the radix point, right? Further you can solve this. So I hope you would be able to solve this, okay? So but by looking at this question, right, you can easily eliminate the option. How can you eliminate the option? So you can see the maximum digit here is 3. Okay, the maximum digit is what? Maximum digit is 3. So your base must be greater than or equal to 4. Your base can be 4 or greater than 4, right? Okay, so in the options, if 1, 2, 3 is given, so you can eliminate and you can directly tell the answer, right? Don't directly attack and get lost in math. But you can solve this kind of a question easily like this, okay? So let me further solve this kind of a question. You can say this 3b square plus 2, 2b is equal to square plus 3 plus 1. b we get cancelled both sides. Okay, so you will get 3b square plus 2 equal to 2b square plus 6 plus 2. 2 get cancelled again. You can say that b square minus 6. So b in minus 6, b equal to 0 and b equal to 6. Now you have to decide which one is correct, right? So as we know that the maximum digit is 3 in this question, right? So answer should not be, the base cannot be 0, because you know that the maximum digit is 3, right? So the base should be greater than or equal to 4. It can be greater than 4 or equal to 4. Answers, the base of this system is 6. Okay. I hope this makes sense for everyone. I hope this makes sense for everyone. So these number of questions. Hi Surajit, yeah, I'm fine. So I'm conducting these sessions, digital circuit sessions, YouTube channel for Gate 2023 on weekends, okay, whenever I get free. I heard that you got selected as a scientist, right? Uh, yeah, if this news is true, then yeah, I got to know from somewhere. I'm very happy for that. The base is okay. So how many questions we have done here? You can see these questions are, but out of all questions, this question was quite good question, right? This question for 3. You can try yourself, but this question is very good question. Okay, so you might get confused, and I think all other questions were very easy. So I think we have done 4 number of questions. Again, I will conduct the session. Okay, part 2 you can say, and here we will talk about few more problem on uh, number system, right? So let's wind up the session here, because session should not go very long. Already it has been 40 minutes. We will meet in the next session. Thank you.